Hello. Today we're going to go over the FE presentation for CEE 300. My name's Nasser Al-Nuaimi. So we're going to talk today about future value, and this comes about from the compound interest formula, where we have future value equals present value times 1 plus the interest rate over the compounding factor to the power compounding factor times t. So what is the future value? The future value is what a lump sum is going to be worth after it has compounded interest over a specified amount of time. So it's needed to determine what an investment's return will be, or the amount of time needed to achieve a certain return if you know what your future value is. So here are some definitions. We have PV, which is our present value, and it's the current value of the investment. FV, future value. This is what the investment will be worth after the elapsed time. I, our interest rate. This asks at what rate does the current investment accrue at each compounding cycle. T, which is the total time of the investment, it's usually in years. N is your compounding frequency. This is how often does the investment compound. So depending on what's stated in the problem, that will determine what our value of n is going to be. So if it says it's compounded annually, n is 1. If it's quarterly, n is 4. Semi-annually, n is 2. Monthly, n is 12. Daily, n is 365. So let's look at the first problem. Suppose you want to take out a student loan for $20,000 with a nominal interest rate of 6% compounded annually. How much is owed after 1 year? So this problem gives us a lot of information, and let's parse all of it out. So the present value is given as 20,000. The interest rate is 6%, which translates to 0.06. The time is 1 year, and because it says that it's compounded annually, our n in this case is going to be 1. The question asks how much is owed after 1 year, so we want to know what is the future value. That means the value after 1 year. So we're solving for the future value. So if we start out with that compound interest formula that I showed in the first slide, we'll basically substitute all of the values that we went over in the last slide. So PV, our present value, is 20,000. Our interest rate is 6%, so 0.06. Because we're compounding annually, n is going to be 1, and the question asks how much it's worth after 1 year, so t is going to be 1. So after evaluating, the answer turns out to be 21,200. So let's go over a slightly similar problem. Almost all of the parameters given in the problem are going to be the same, except for one. The question reads, now suppose you take out a student loan for $20,000 with a nominal interest rate of 6% compounded monthly. How much is owed after 1 year? So let's see what the given information is this time. So the present value is still 20,000, interest rate still 6%, time still asking how much is owed after 1 year, but this time we say that it's compounded monthly, so in this case n is going to be 12. So what are we solving for? We're solving for the future value because we want to know how much is owed after 1 year. So let's go over the solution. We're going to use the compounding interest formula, and we're going to substitute the values that we have in this problem instead. So the present value is still 20,000, interest rate still 6%, but now because we're compounding monthly, we're going to be using an n of 12. The problem still asks how much the lump sum of 20,000 is going to be worth after 1 year, so t is still going to be 1. When we evaluate this, we find a future value of $21,233.56. Rounded to the nearest dollar, this becomes 21,234. So this means that after 1 year, at an interest rate of 6% compounded monthly, we're going to have a future value of $21,234 from the initial lump sum of $20,000 that we started out with, and this is the new amount that's going to be owed after a year.